Okay, for this example, we are going to be designing an XS3 to binary decoder and a binary to XS3 decoder using the unused combinations of the code as our don't cares. For this example, I created our XS3 as our W, X, Y, and Z, and our binary is going to be A, B, C, and D. So over here, I created our truth table. So our binary is in blue on the left, and our XS3 is in red on the right. As you can see on the left, our A, B, C, D, our binary goes from 0 to 9. So our don't cares are everything that our binary is not. So that's 10, 11, 12, 13, 14, 15. Because we have 4 variables, the max amount is 16 values, but we start at 0, so it's 0 through 15. So you see our don't cares on the left. On the right, for our W, X, Y, and Z, that's our XS3. So XS3 is whatever binary is, it's plus 3. So as we can see here, for our first one, it's 0 plus 3, which is 3. 1 plus 3, 4. 2 plus 3, 5, and so on and so forth. So our don't care conditions are everything that our XS3 is not. So our don't cares for this are 0, 1, 2, 13, 14, and 15. Now, I'm going to start with our binary to XS3, and then we're going to go from XS3 to binary. To start this, what we're going to do, I already created all the K-maps and everything. We are going to start with our W in all of these values, and we're going to create a K-map for this. Then we're going to go for our X, our Y, and our Z. And from our K-map, we're going to create a equation. And from those equations, that's our decoder. So I'm going to start with W, and then we're going to go forward. So I already wrote down our ones. So our ones for this are 5, 6, 7, 8, and 9. So for this, we're just going to write ones wherever our ones are. So I have it in 5 already. 6, 7, 8, and 9. Now, we can use our don't cares as ones or zeros. For this, I'm going to be doing ones. So I need to make the largest groups possible. So for this one, for these two, we have it here. So that's our largest group possible for this. So I'm going to write this down. W equals, I'm going to do the same color so we can tell this is just A, because A is 1. Then we're going to go into our next one. So this is going to be this group here for this one, because we need to create the largest group possible. So for this, it's going to be B, C, because B is 1 and C is 1. And then for our last one, it's going to be this group here. And that is going to be our plus B and D. So this here, I'm going to box it. This here is our formula for W, which we then can create into a circuit. Next is our X. So we're going to go through. All right, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Now we're going to fill in our ones. So we have 1, 2, 3, 4, and 9. Okay. For this, we need to create our largest groups possible. So for our first one, I'll pick purple. It is this one here and this one here. Our next one is going to be this one here and these here. And our last one is going to be these two here, because we don't have another one over here. So we can't use that. So formula is x equals, I'm going to start with the orange one. Orange is b prime d plus, now I'll do the green one. This is going to be b, I'm going to do c first. D, c prime, d prime. And then our purple one, which is b prime c. So this is our equation for x. Next is our y. Let's do the same thing. Just fill in. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. I'm not going to keep going. So we have 0, 3, 4, 7, and 8. Okay, so we can see our largest groups here are these 4 and these 4. So, we're going to formula out. Y equals, this one is c prime d prime plus our c d. For z, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. Fill it in. 0, 2, 4, 6, and 8. We can see our largest group here. Oh, I'm sorry, hold on. Before we start this, our largest group is going to be these 4 here and these 4 here. So z is equal to d prime. So this is our binary to XS3. You're going to take all of these here, this one, this one, this one, and this one, and you're going to create a circuit for each of these, and that is your XS3, sorry, your binary to XS3. Now we're going to do our XS3 to binary. I already marked off all of our don't cares that are up front here, if you write them down. And I marked them down for each of them. So we're going to go through and we're going to fill them in. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth. So fill in our ones, 1 and 1. So our largest groups for this one are this one and these ones. So A is equal to WX or WYZ. Then we'll go on to our next one, our B. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth. So we're going to fill them all in. 7, 8, 9, 10. So we're going to look for our largest groups possible. We see the corners. We can use all the corners. And the last ones we have are, there are a few options for this one. Sorry, there's only one option for this one. It's actually going to be these two and these two. Those are our largest groups for this one. Now for the middle, we just have this group. So for B equals, so I'm going to start with, let's start with red. Red are all the corners. So that is x prime z prime. Or, then we do purple. That is x prime y prime. Then we're going to do orange. Orange is x, y, and z. Now we're going to do our C. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth. Fill them all in. 5, 6, 9, and 10. You can see our largest groups right away are this group and this group. So for this, C is equal to, we're going to do orange first, it is y prime z, or then we're going to do our blue group, this is our yz prime. And for our last one, D, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth. We're just going to fill them in. 4, 6, 8, 10, and 12. For this one, our largest groups are the outsides. Here. So D is equal to Z prime. Now, all you're going to do, the same as the last one, you are going to create a circuit using A, B, C, and D. If you need help with that, let me know. I'm more than happy to make another video about creating the circuits for this if you do need that help. Besides that, have a good day.